Hi together and welcome to today's webinar hosted by the Open Telekom Cloud community. Today we have our guest here, Daniel Schellhase. You may already know him from one of the last webinars. It's already a known face. And yeah, today he will talk about the Object Storage Service, the OBS known. And yeah, so hi Daniel.
Hi, Stefan. Thanks for giving me the opportunity to introduce to you today the Object Storage Service. The session is called Deep Dive into Object Storage Service. So we will go through the functionality of Object Storage. What is the use case of the Object Storage Service? What are the functionalities? Why do you need these functionalities? Or for which purpose do you need them? And of course, at the end of the session, and what I would even guide you through is even to give you a better explanation and a more deep dive explanation about how the service is priced. So how does pricing works? So let's start very basic. So what exactly is Object Storage Service? And of course, here, I suppose everyone might be aware, should be aware that the Object Storage Service has a very flat hierarchy. So you normally put your objects into a bucket and assign objects to a bucket where they are either stored in a very flat hierarchy or structure. So the advantage of this one is, of course, that the Object Storage Service is easy scalable. It's a perfect fit for unstructured data and static content. And of course, throughout the tools which we have available, it's easy manageable and accessible. That's the basic advantages of Object Storage Service. And if we consider use cases, and this is just an overview, of course, use cases could be something like a video surveillance where you put in data which should be then maybe deleted after a specific period of time, coming from video surveillance systems, file services, data lakes, big data analytics, media and entertainment items, and of course, backup and recovery. So it's even a very popular use case that Object Storage Service is used for backup and recovery purpose. So meaning that you on-premise generate, for example, the backup and store it in a cloud infrastructure like the OBS, where it's replicated to even different availability zones. And here I would like to give you highlights. Of course, we will get through all the items and the contents in detail throughout the session. But here are the highlights of the OBS. It's nearly limitless scalable cloud storage. It's highly available, as you might know. We're granting 99.95% availability. And it's durable, so up to 12 nines. What we have available here as well, the Object Storage Service is designed that it's replicated into 3 availability zones, so it protects for a potential disaster. And we are providing here 3 storage classes, standard, warm, cold. We will even get through this item, which gives you a perfect fit for your individual storage demands. Security, we have a lot of security features at the heart of the service, which we'll even introduce to you throughout the session. And of course, the OBS is completely pay-per-use. So if you use and consume the service, if you have transaction on the service, you will pay for this one. But we will even throughout the session give you a very in-depth explanation about what is charged, how it is charged, how does it work in depth. But this comes a little bit later, maybe. So here's an overview about the structure of the service. Of course, the OBS is, as I've already explained, replicating data throughout the 3 availability zone. It's accessible via the internet, and of course can be accessed throughout ECS, CCIE, or BMS instances, of course. But let's now start with the introduction. So as I already explained, the OBS has a very flat structure. So this solution allows to store the objects in buckets. So you're able to create up to 100 buckets in the Open Telekom Cloud. You know, this is the current quota which is set up. And of course, you can expand this via a service request. We have here for the OBS service, there is no hierarchy, as every objects, so meaning these objects have a unique global ID, independent what kind of object it is, or file or video file or whatever you're storing outside. So the focus on the service is really on storing and retrieval of objects. That's the focus of the service. But as I explained, it has a flat hierarchy. You even can create folder structures inside the OBS service. So OBS supports that you can organize data in folder structures. But here as well, the representation is done with the slash here. So folders, but just to keep this in mind, folders are just a logical representation of the object name. So normally the object name contains then here the slash, and this represents on a software layer that there is a folder inside, right? Here I have an example for you where we have just a picture on the first layer, then we've created a folder and a subfolder, and they are accessible via this URL, very easy. And this, of course, represents and always the different folder levels. And of course, inside the UI, inside the user interface, or OTC console even named, you can even then see the folders here. So if, for example, I create a folder and I name it level 1/level 2, then of course these two folders are created and represented inside the user interface of the object storage service. But I suppose most of you already know this, because it's very standard. So if you create this, I already explained, then you see in the user interface the different levels of folders are created. So, and then of course you can even store inside these folders if you use the UI very conveniently. Here another example where I stored an object inside this folder level, and you see here in the link to that you see here the level 1, level 2 element for the folders, which are basically an object name. But this just as an introduction that you can work with folders with inside OBS. I would like to come now to the basic functionalities which are given. I will even give you later on an introduction to advanced features, so this is not everything which we have, but I would like to first start with the basic functionalities. So what can you do with the buckets? Of course, you can create a bucket, you can delete a bucket. Here it's important to be aware of that you need to delete all the objects inside a bucket before you can delete a bucket. You can, of course, create a folder inside a bucket, as I've already explained. You can change the storage class for the bucket. We are coming to that topic in particular a little later, where I explain to you the exact behavior of that one. So, but I already made a note. So if you change the storage class of the bucket, this does not have any impact on the already stored objects inside the bucket. But I will come to that in a second. And we have some advanced functionalities on buckets, which I even will introduce to you later. Objects, what you can do here is, of course, you can upload an object, of course, towards the upload towards the upload, you can assign a storage class, you can encrypt an object, you can delete an object, you can download it, add metadata, change the storage class of an object, as well as you have advanced functionalities. But as I already introduced to you here that you can change storage classes and there are storage classes, I would like to directly jump into the topic that we have storage classes here and different ones. I already explained. So we have here three different storage classes: standard, warm, and cold, which are available for different purpose and use cases. Of course, the standard one has, of course, top performance, reliability, and availability. Warm is even in real-time available, it's even a real-time storage, but more inexpensive, more for web disk application, enterprise backup, active archiving, data monitoring, while standard is really for cloud applications, data and content sharing, and hot data storage where you need really regular access to that storage. Code is, of course, for archive purpose. If you need to store, for example, video materials which you need to hold for a specific period of time, it can be used as a replacement of tape libraries. You see here the durability and availability values which we have here. All three have a redundancy and three availability zones. So the data, if you store any data inside the OBS, they are replicated to three availability zones. And as I already have introduced throughout the last webinar, which I hold, which was covering the backup services, you might be aware that we are using the OBS even for storing the data coming from the backup services. So this means even when you use one of the backup services like CBR, for example, Cloud Backup and Recovery, which gives you the option to back up your ECS, EVS, and SFS Turbo instances, then of course they are even replicated to three availability zones. We have a minimum data duration, so the data needs to be kept in warm for at least 30 days and for cold for 90 days. Otherwise, you might be aware that there is this so-called early delete penalty, which is basically charging you for the rest of the days if you have deleted the files before the period or the duration time has been reached. Access latency for standard has the lowest, warm low, And for cold, you might be aware that we have 3 kind of access speed types. Expedited, which is giving you access to the object in 1 to 5 minutes. We have standard, which gives you access to the object in speed with, until 5 hours, and bulk 5 to 12 hours. But we're coming to that item in some of the next slides as well to explain to you how this exactly works and even to discuss the first pricing elements. If you consider now, based on the access use cases pricing, what to pick when, then I can give you a good information about this. So standard should be used if you need really daily or frequent access with lowest latency. Then you should store your data really on the standard storage class. If you have up to 1 access per month, then you should select warm. So 1 access per month is really possible, even from a commercial point of view, that you go here with the warm one. So if you think you need this data, but you need very infrequent access, then you should really select the warm class for this one, because it's storing the data for a lower price, but even if the data is available in real time, so gives you nearly instant access to the data. And for code, this is a little bit more complicated because, as you might be aware, there is different pricing based on the speed type, but you can say here that every half a year with expedited access, that an access is here recommended. You can have up to 4 times a month access with 5 to 12 hours, delayed access, which means bulk access, and 1 day data availability. As you might be aware, this data needs to even be restored on the code, and you need to define how long this data should be available, and you're charged for these data availability as well. But we are coming even to that one. I've some slides prepared for this one to explain to you that one. And we have here for even up to 2 times a month with the bulk access, 5 to 12 hours, when you want to have the data available for 1 week. So then you can have even 2 times access for code data. But here as well, as explained, you need to then wait for the data to be available or to be made available. So let's come a little bit more into the details of storage classes. So I would like to give you more details and insights about this one. I already explained that we have here that you can assign to a bucket storage class, and I would like to explain to you the behavior of that one. Objects, and as I've already explained, you can define throughout the upload process of an object which storage class should be assigned. And so you can store objects which have the storage class assigned warm or cold in a bucket with the storage class assigned standard. So the storage class assignment on the bucket level is only there if you have not defined any class. Then the object will inherit the storage class defined by the bucket. So in this case here, of course, it inherits the object C inherits the standard class standard, and so receives the standard class. That's basically the functionality, how you inherit the and how the storage class for buckets work. Then we have here the object stored, and let's consider now we are switching the storage class for the bucket. So if I switch it and change the bucket class to code, then nothing will happen on the objects which are already inside the bucket, because it's really just for the purpose that if you have not assigned any object and you upload it, it just inherits the storage class defined by the bucket. So I would like to give you an example here for the storage classes standard and warm, because they are most easy to explain. We come to code in a second. So the standard class, as already explained, is instant, accessible, and available. The same appears for the warm. There is, as you might be aware of, restore, respectively, access volume priced in addition. And I will give you an example based on the price list. If you have 1 access per month, then of course, there's a request even in place, but we now don't look into the request right now, because it would not have too much impact on a per 1 object basis. So therefore, if you just compare here the pricing for the storage of the standard, and you take the pricing and the restore volume per warm, then you see that you can only do 1 access on warm. Then you are a little bit cheaper compared to the standard class. So therefore, I would recommend that normally the use case should be for warm to have 1 access per month. Then you're slightly cheaper. If you have less, of course, it's getting more beneficial for you. This, of course, as explained in a simplified example, I've not included here the requests. We are coming to that later on to the requests, how they are counted. But here, if I would account one request for storing the data, it would not have that much of an impact for the pricing. So how does this cold storage class work? So for the cold storage class, you have the object, and if you're executing a restore, and this basically virtually now explained creates a copy of the object that is available for a specific amount of days, and you specify this. And you define here as well in which speed type you would like to have it accessible. And I already explained this. You have expedited, standard, and bulk. And here you have the times for expedited 1 to 5 minutes. The object will be available for standard 3 to 5 hours, and for the bulk in 5 to 12 hours, the object will be available. That's what you define. And if we now consider the pricing and how it's charged, of course, explanation here is cold pricing is, of course, for restoring or access a file is, of course, based on the speed type. And you see this in the price list. So it's you have the restore request per speed type, which is basically I would like to have it available in 1 to 5 minutes, 3 to 5 hours, 5 to 12 hours. So for this request per speed type, you have to pay the volume defined in the price list. And you have the volume as well for the file itself. This is even charged. That are the two items which are charged per speed type, I would say. And you, of course, pay for the copy. So there's this code object storage buffer inside the price list, which you might have seen. That's basically the availability of the copy which is then charged in a day basis. Of course, it's defined in the prices per month, but of course, you only pay for what you have defined here for the days. Let's get to the next item, the early delete. And here I explained to you that you have to store the data for at least 30 days for the worm. So if you have assigned the storage class worm to an object, the data needs to be stored at least 30 days. For cold, we have here 90 days in place. And so if you delete, for example, an object with the storage class worm, and you delete it before the 30 days has been reached, you will be charged, and this is even what you see then on your invoice, an early delete penalty where you have to pay for the remaining days which are left. And here I have an example for you. If you, for example, have stored a worm object and you delete this at day 15, then of course the early delete comes in place and you have to pay for the rest of the 15 days, which would then achieve the 30 days. And for code here, another example, if you have stored a code object and you're going to delete this as at day 30, then you get charged for the 60 days early delete penalty. And here I would like to make a recommendation to you. If you look into the price list, it's much more valuable to make sure that, for example, the data is kept for at least the minimum days of time. Because in some cases, it's even a little bit cheaper, especially in the code object case. So therefore, I would recommend that you make sure that you achieve these days. Of course, you can use lifecycle rules for this one. I will even come to the topic in a second. That's how the storage class works. So now I would like to come to more advanced functionalities of the OBS. And I will jump into the topic of lifecycle rules, versioning, logging, permission management, event notifications, default encryptions, website topics, as well as inventories. Inventories only available for the Swiss cloud, but of course, here as well, we will see an upgrade in some time, which gives even the functionality inside the DE and NL region. So let's start with lifecycle rules. What exactly is lifecycle rules for those of you which might have not used them so far? Lifecycle rules enables you to automatically put an object to a specified class or to a specific class, or can even delete it if by the rule definition. So if you have an object, like here object A, which is assigned to the standard class, you can define here that, for example, in 30 days, it's automatically moved to warm. After 30 days, it's moved to cold, and then you keep it for 305 days until you delete it. That's an example what you can do with rules, so that the object automatically goes to the cheaper storage, because maybe you expect if you collect the object, it's maybe regular access throughout the first month. Then the next month you expect, okay, less access, maybe one access, then you put it into warm. And afterwards, for the rest of the year, you put it into cold because you don't expect any request for that object, but you need to keep it. And then after 1 year, you say, okay, I get rid of it because I don't want to pay for the object and for the storage of that object. So this is what you can automate by using lifecycle rules. And I would go into the details. So lifecycle rules are specified per bucket. So this would then apply to all objects which are stored in a bucket. So if you define this rule, you can define here, even if you would like to specify it for a prefix. Prefix means it's only applicable for objects which have inside the name a specific prefix included. And here you can even define multiple rules. So then you can even create multiple rules. So here, for example, I have an example for you. Here I created a lifecycle rule. Here's a status, and I enable it and name it 36 350 65. And if I define it here on object prefix naming, I can define multiple later on, multiple rules of lifecycle. And I can configure here the prefix for this one. And then here's the example for this prefix. So I have here 3 objects, and you see it already. It's very simple example. We have here the lifecycle rule will be applied to that object because this fits to the naming convention, to the prefix which we have defined, as you can see here, and for object 3 as well. As mentioned, you can define multiple rules per bucket. When you use the prefix functionality, you can only use one rule per bucket if you use the per bucket. So this is I hope very clear here with the visual representation. So here is the rule configuration. Rules can be applied to the current version of an object if you have versioning enabled. We're coming to the topic in a second. What happens if I have versioning enabled? But at this point in time, it will take an effect on objects which are here uploaded to OBS. So you can configure here the transition time to warm. If you want to configure, you can even disable it. Then you can say, okay, transition is after 30 days. Or here in the case of cold, it transitions it to 60 days. And it's even the functionality and the UI responds, of course, even to the early delete times. So that it starts here when you put something into warm, that you need to keep it for at least 30 days. It's even configurable here. Here, the expiration time means the delete functionality. So here, I want to make you aware that this is even available, that you can delete then the objects. Let's go to the next topic, and then we shortly jump back to lifecycle rules. So versioning allows you to store multiple versions of an object within the same bucket. So if you enable the functionality, which is even a bucket level functionality, this allows you to receive a recycle bin functionality as well. So you receive it and you can store a different version of the same object. And you can even assign here a different storage class to that one. So that's basically my example here. So I have here version 1 of that object A, which is stored on code. And I can even store another version of the object, which is stored on standard, which is version 2. And what you have as advantage as well is, of course, if you have enabled versioning, you have a recycle bin functionality, which of course protects you against accidental data deletion, or you overwrite an object, or even if you have an application layer on top, that maybe throughout application failures, this is then even overwriting or accidentally deleting the data. But the downside, of course, is that you have an increased storage consumption. So because every version of an object is stored separately and consumes separate storage. So I give you an example for this one. If you have, for example, a movie, and you have the version 1 of that movie, which takes 1 gigabyte. And then you add, for example, here an intro of that one, which is then version 2, which is maybe not consuming so much space, but you store it with versioning enabled. Then you have, then you need to multiply here the storage consumptions. So that's an item which you need to consider when you're using versioning here. But I have a good information for you in a second. So versioning gives you and grants you access to a kind of recycle bin function. So if you delete an object, then the deletion of the object will put the object into the deleted objects from an UI perspective. You can see this here. So you have kind of recycle bin functionality which protects you. But if you go into the exact version of the object, so if you go into the object and you see here throughout the object the versions, and you delete it from with that one, then of course it's not going into the recycle bin. So here you need to be very careful, because if you go into the dedicated version, you delete it there, then it's deleted. So there's no fallback there. That's what I want to mention here. I mentioned already that we have the lifecycle rules available. and I said it's for current version. We have even the functionality for historical versions, which means if you have enabled versioning and it's not the latest version of the object, then you can even define rules for historical versions, because I already said, okay, it's multiplying the storage consumptions, but here it's a very useful functionality that you use here lifecycle rules to get rid of old versions of your object. So that's what you can configure. So you can even configure here on current and historical version lifecycle rules, so you can get rid of data which is stored in historical versions. So that's what I want to mention. So that's even maybe something which helps you to improve your data consumption as well as data management. So therefore, my recommendation: make use of the lifecycle rules in versioning in combination, and then you can improve your protection against accidental data deletion, and of course, with lifecycle rules, improve your consumption of data. Let's get to logging. Of course, logging is even available, so you can enable logging inside on a per bucket level, which is a very basic feature. You just can enable and disable it. You can then define the bucket where it should be stored, and of course you can define, and it's predefined, of course, and folder where it is then stored. So if you enable it, then of course it will be stored inside these folders. So here you see there's these slash, which gives me the folder functionality, and then inside this folder all the logs are stored. And that's a very basic functionality here. Then we're coming to a more complex functionality, which is permission management. So I'm not sure how familiar you are with all the permissions which are available, but I would like to give you here a good introduction into what kind of permissions are given in OPS and how to configure this. What you need to consider here when you configure permissions in OBS is that we have 3 levels of functionalities. We have, from a permission management point of view, we have the IAM, the Identity Access Management functionality, Identity and Access Management, which you might be aware, which is an service overspanning Identity and Access Management service. Here you can define who is allowed to execute which action on OBS, and it's of course service spanning. So you can configure this over all the services. I suppose you're aware about this. Then we have the bucket and object policy, which you can define directly on the OBS, which enables you to grant permissions to IAM users or other accounts on bucket or object level. And you have the ACLs, access control list, which provides you the ability to control write and read permissions for specific accounts. So we are deep diving now a little bit more into the topics of these 3 functionalities. So you have a good overview about what are the difference of this, what should I pick for which purpose. So we will deep dive into that one. But for the time being, I would like to come to a side topic with you, because we are currently implementing the IAM fine-grained policies. I'm not sure if you're aware of what this is, fine-grained policies, for the OBS service. So if you look into the OTC platform, you can see that the IAM fine-grained policies are already implemented inside the platform. And we are even implementing this right now for a lot of other services. So you will see within the next couple of weeks and even maybe months, depending on the service, that we're going to implement this. What exactly is it? So some of you have already seen maybe the functionality that you can create your custom policy for IAM to grant an administrator and user access to a specific service, or even prevent them to access a service and configure a service. With fine-grained policies, you're able to get into the policy designer, which allows you to create a custom policy. You can give a policy name, and then you can select the service name, like for example here, and it guides you through the process of configuration. So you say here, okay, I would like to have object storage service, and then you can granularly define which action a user is allowed to take or not to take. So you see here on the read side, we have a lot of actions which can be configured on the write, on list, and even I think generic permissions. So, and this is what we are meaning with fine-grained policies, that you really granularly define which action a user is allowed or an administrator is allowed to do and execute or not to do and execute. So this is already implemented, and this is what I would like to mention to you, because this has an impact on how you will see the platform within the next couple of, from now onwards, more or less. So I said it tomorrow because basically we will see a release notes once we're currently making sanity checks. So the functionality is released. We're doing sanity checks on this one. So you will see an official release notes once all the sanity checks have been done and we say, okay, everything is working as expected, which we expect is fine. But anyway, we are doing sanity checks. I would like to give you an example about what is the difference between the services. So the bucket ACL, access control list, gives you only access to define who is allowed to read or write on the bucket and on the objects. That's what you can do here. But you can only define that you are able to access all objects inside the specified bucket. And so it's a functionality which has only read and write permission and is only spanning over a bucket, and you cannot really granularly define this. If we now go into the policy, bucket policies, here you have even fine-grained access rights. So you can define on a bucket or even on an object level what a user should be allowed or not allowed to do on the bucket. So this includes even a conditioning that you, for example, put conditions into which should appear once someone should be allowed to do something. And if you look into the EAM, it's spanning over, you can define it that it's spanning over all the buckets because it can span all the buckets. You can define it on a bucket level and you can define it on an object level. So it's the most granular functionality which we have in our portfolio here to define this. And here I would like to give you an overview to make it more clear what is the difference about the functionalities. Here it's EAM, the policy, the bucket ACL. So here you see that you have nearly all functionalities are given. You have bucket spanning access rights, so you can provide access rights to multiple buckets at once, which is not possible with the policy at ACL because it's on a bucket level. You need to configure this. But of course, here you can have bucket level access rights for EAM, policy, and ACL. On an object level, you can only specify this for EAM and the bucket policy. You cannot, for example, define in the ACL that someone should not do something. It's not an explicit deny. We will come to the topic in a second. But on a policy level and an EAM level, you can do this. Fine-grained access rights are given for EAM as well as for the bucket policy. So you can here define fine-grained access rights. But for ACL, it's only read and write, which I would now here say it's not really fine-grained access rights. Even yet you can define read and write, I would not call it fine-grained. Therefore, you have only 4 actions which you can do. And for the others, for EAM and the policy, you see you can do much more. For the policy, you have 35 actions, and for the EAM, you have 61 actions. 4 are more or less the generic, that you, for example, define that generic get is available or put is available. That's the 4 generic actions, I would say. And from a conditional point of view, if you would like to make use of conditions, you have here for the EAM 22 conditional parameters and for the policy 12 conditional parameters. So what you can see is that, of course, EAM is the most advanced, which requires the most attention if you configure this. ACL is very basic, where you only configure read and write access. So it depends really on your use case and what you want to do, which one to pick and which one to configure. But now I expect you will ask me, Daniel, what happens if I configure an ACL, a policy, and an EAM? And maybe there is some cross-references inside. We will come to that now. So if you configure all of this, there is some kind of access decision be done inside the platform, which checks all the policies. So if you have configured EAM, if you have configured the ACL, if you have configured the bucket policy, then it checks all the policies. And it checks if an explicit deny is set. So have you set an explicit deny on the user to get access to a specific resource or to perform a specific action, and it identifies, oh, there's a specific deny set in any of these servers, then it will result into a deny. You don't have access. If it doesn't find any deny, then it checks, is an allow available? So have you defined that this user is allowed to perform this action on this resource? If no, then there is still the deny, and if yes, a yes will appear. And I created for you a small matrix which gives you an overview what will happen when which happens. So here you can, on ICL level, you can specify an explicit deny. You have seen this red marked maybe, and you ask me what this is. So you cannot say a user is not allowed to, for example, read or write on that bucket. This is not possible inside the ACL. So if you have not allowed this, we call it default deny if you have not granted the access. It's a default deny, not an explicit deny. And if you, for example, have a deny on any of these servers, an explicit, it will always result into a deny. If you have an allow and only a default deny, as you can see here, for example, here's a default deny on EAM policy, ACL default deny, but you set allow on bucket policy, then the user is allowed to access this data. So this is a matrix which we set up to give you a better introduction into how does these matrix work and how is the decision made if someone is allowed to do something or not. If, of course, everything is allowed, like here, EAM policy allow, ACL, and bucket policy, of course, it's allowed. So let's get further through the functionality. So event notifications. What is this? And event notifications informs you once an object is removed or created. So you can configure that you want to get a notification if objects are removed or created. And here you can even specify by object name a prefix or a suffix, which would filter the notifications. So you can define if an object starts with this term or ends with this term, that you would like to get only notifications for these kind of objects. So, and this means more or less event notifications means you can get a notification if you're uploading an object or if you're deleting an object. And we're using here the simple message notification service. I'm not going into the SMN service right now to send the notifications. So this is a configuration that you need to do on the SMN. So because the event notifications is basically taking the configuration of SMN, and then you can get a notification, whatever you have then configured on the SMN. Default encryption is a feature which we have released, I think, October last year, if I'm not wrong. It should be October last year. And default encryptions allows you to encrypt all newly uploaded objects on default, which are stored inside the bucket. And this even implies that if you, for example, enable logging. I showed to you that, for example, logging creates the log files directly into the defined bucket. So if you enable the default encryption, even your log files will be encrypted. That's basically one of the use cases why this functionality is existing, because even when log files are created, you would like to maybe encrypt them, but nevertheless, let's go into the functionality. So if you have a bucket and there are already objects available, and you then set up, say, okay, I would like to enable now default encryption. This has no impact on existing objects. So you see here, object A, B, C is not encrypted. It's only for newly uploaded objects. It's not on default encrypting all other elements and all other objects inside the bucket. So it's really just for the newly uploaded. And if you then set default encryption to off, then of course it's off and a newly uploaded object will not be encrypted any longer. So this is the behavior of default encryption, because the expectation could be that maybe all are then encrypted. No, it really has no impact on already existing objects, only on new. Same behavior which we have seen with the storage class, which you can assign to a bucket. No impact if you change this on existing, only on newly uploaded objects. So same behavior. Just to be here very precise on how this works and how the behavior of this default encryption is. Let's continue. Website. So we have the functionality of static website hosting. What is static website hosting? Static websites are websites which are basically where the content inside the website basically doesn't need any change, where no interaction is required from a user perspective, where it's just a plain HTML document with maybe some JavaScript, CSS for those which are developing maybe websites, and just creates then, for example, the web page. An example would be, for example, our docs page, which you are aware, is, for example, a static website. Because there's no interaction, you just browse through the content, you read the content, etc. Where a dynamic website includes a programming language, database access, where you need to do interactions with the users, where the OTC console or UI is exactly that example. So the content here depends even on interaction, on user login, on the database, these items. That's basically, for those which are not aware about this, that's the difference between static and dynamic websites. without going into the technological differences in detail. So static website. So what do we have here in OBS? With OBS, you can exactly store static websites and make it accessible, which means you don't need to set up a web server. There is no necessary capacities which need to be established or resourced because you're not basically creating a server for this one. So you even save the resources for administration and maintenance of these server. That's basically the advantage if you use static website hosting directly on the OBS. Then we have on the website functionality, because I just summarized all these functionalities, now we're coming to a different feature. And with different feature, I mean course rules. For those which are developing web applications, I'm not sure if any one of you are doing this. You might know about the same origin policy called SOP, which prevents access from different domains and sources. With the course rule, you can specify and even allow this request to be made. So I don't want to deep dive now into the topic because I'm expecting there's a lot of people which are not doing web development here. But for those which are doing web development here with the course rules, you can even allow these course origin resource sharing and requests to be made. And we have the URL validation, which allows you to protect your. If you, for example, we take an example, you have a website and you've put an image on this. This image, of course, has a URL. And if you want to protect this cannot be used by other websites and you have to pay for the access, right? Then you can do this URL validation. And you can whitelist or blacklist list this. So you can basically allow access from a specific URL and you can even deny and to an explicit deny to access from this URL. The logic, if you have configured whitelist or blacklist feature, is very easy. If you configure whitelist only, then only whitelisted URLs can access these OBS content. If you do both, then even only whitelisted URL can access. So that's because then normally it doesn't make sense to then configure even a blacklist. If you don't configure this, all URLs can access the resource, and if you configure only the blacklist, then all URLs except the blacklisted can access the resource. That's basically the logic behind the whitelist and blacklist feature, which you have here in URL validation. But use case is basically that not every URL can access your resource and implement it and can make use of it. Then we have a functionality which is currently only available in the so-called Swiss cloud in our CH region, but which will come up later on even in our DENL region. Therefore, I would like to even highlight this. Maybe there's someone here which is interested into the Swiss cloud topics. Here we have with the Inventories functionality, you can export a list of all the objects which are stored inside a bucket as CSV. For example, if you need it for analysis purpose or something like this, then an export, then the CSV list is created and even stored in the bucket. Here's the functionality which you can configure. You can even configure a filter by prefix. You can say, I would like to have these inventories list daily or weekly. So this CSV list is created daily or weekly. You can say, I would like to include only the current version. So remember, if version is enabled, you have the current version and the old historical versions. So this means really only the actual current available versions. If you want to have even the historical ones, if you have enabled, for example, versioning, then you need to activate your all versions. And you can even make sure that you get additional data fields, like, for example, the size of the object, the date of it when it was last modified, e-take, multipart, upload, replication status, and encryption status. That's what you can even get here. Let's go to the service interdependencies. So you have, as I already mentioned, you have an EM and interdependency. We are recording logs of the OBS inside the CTS. I already explained to you that SMN is, for example, used for the event notifications, KMS, key management service, which is encrypting. I would like to come to the pricing logic of OBS. So we are now finished the functionality. Now I would like to come to the pricing logic because we are receiving a lot of questions related to how does exactly work the pricing? What kind of requests are implemented? So this now is a session where we deep dive into exactly the pricing logic. And I would like to explain to you in depth how it works. So we have here the object storage service and the pricing logic of OBS, which is a very transactional pricing. So if you create objects, if you store objects, if you access them, modify, delete them, you will pay for that. So every transaction you will pay. And now throughout this presentation, we are going more and more into the depths, what exactly is happening, so that you get a good overview about this. So as already explained, we have the three storage classes, standard, warm, and cold. And if you want to, the performance, the accessibility, and the price increases here based on this hierarchy that you go to standard from cold to standard. That's what I already explained to you. And if we now just consider the regular accesses, what we're doing. So we have here standard, warm, cold. We are storing data, we're accessing data, we're deleting data, and sometimes we even need to transition data, so moving data from one class to another class, because we want to move, for example, old data to a cheaper class because the probability is lower that it's getting accessed, as an example. So we are now looking into all the details of storing, accessing, deleting, and transitioning of data, and I will explain to you in detail how this works. So let's first start with a simple item, with the storing of data. That's the most simplest item. So if you store data, you of course need to pay for the storage cost, so the consumed storage size per month per class, which is, I suppose, what you're aware. Then you have a transaction fee, because if you store an object, you need to there will be a request done. So and now we are coming a little bit closer to how requests are working. And here, for storing a data, a dedicated put request will be done based on where you're putting these object to. If you put it to the standard class, the standard put request will be done. If you put it on warm, the warm put request will be done, and on cold, the cold put request. That's what you will pay for if you are storing data inside OBS. So these two items. So as you know, we have here a tiered pricing with for the three classes, standard, warm, and cold. So we have here a tiered pricing, which means you have a dedicated price from if you store data from up to 5 gigabyte. The next 995 gigabyte has a pricing, and so on. So that's basically the logic which we have behind the pricing, that first 5 gigabyte have a price, the next 959, the next 49,000, and so on. That's the logic which you have. And what is done then is, I think you know this example from maybe one of the price explanation documents which we have available. We are, of course, tracking the consumption which you have in average throughout the time. So we are tracking the consumption you have per storage class, and then you have to pay for this. So if we identify, okay, this is 2000 gigabyte which you have consumed in average, then of course the calculation is done in, of course, for the standard class, the first 5 gigabyte is free. So you don't have to pay for them. So the next 995, you have to pay €2.20. This is per standard per price list. The German price list, I have to say, and for the German region. And here the next item, the next 1000 will be then taken from the third tiered pricing level. So what I would like to mention here is that the storage class tiered pricing is independently accounted. So that is what I would like to mention. So if you use standard, warm, cold, it's independently accounted and taken into consideration from accounting perspective. That's basically how the storing is charged. So you basically have the put request and you have the storage costs which you have in place for the consumed storage. Then we're going to deletion, because access will be a little bit more complicated. That's the reason why I decided let's go first to deletion of data. So deletion is very easy, because here you have even the so-called delete request, which is even a transaction fee per object, per class, which you have to pay. So if you delete an object from standard, from warm or cold, you have to pay these delete requests. And what's taken even into consideration is this early delete penalty. As mentioned, you have this minimum data duration time of 30 days and 90 days for warm and cold. And the early deletion fee is applicable once you delete the data before the time frame. So you're charged for the remaining days. That's how the deletion of data is charged. So very easy. I added here delete request. Here for warm, we have the delete request and the early delete, which needs to be considered. Same for cold, delete request, early delete, which needs to be considered. I explained access is a little bit more complicated. Therefore, let's have a look at this at the end. Now let's take a look at transition. So you want to move data from one class to the next class. For example, you have standard and you want to put it to warm. You have this transaction fee per object per class transition to warm. So you have the warm transition request for that one. So the logic is you transition to warm. Here as well, standard to cold, you have the transaction fee per object per class, transition cold. So you have to pay for the cold transition request for that one if you put it into. Now let's look into if you put warm to standard. Here you need to be aware that if you transition a warm object to standard, that the early delete penalty is still applicable. From a pricing perspective, this is like a deletion. Please keep this in mind so that if you cannot just put warm to standard, this is even then charged if you change the storage class and the 30 days has not been achieved. Same for code. So early delete is even here available. So if you put, for example, code to standard, early delete is applicable. If you put warm to code, now this item, then of course you have to pay the cold transition request because it's the object is put into cold. And here even you have to consider the early delete, which could be applicable once you move it before the 30 days of storing in warm. And the other way around, cold to warm, you have to calculate the cost of the warm transition. And here even the early delete is applicable here as well. That's basically how the logic works. Logic basically is you have to pay to warm the transition request. I would call it too warm and too cold. And optionally, you have to consider always if you move it out of this class, the early delete. That's basically. Let's look into accessing of data and objects. So here, this is what I've already shown to you, right? So standard is instant accessible and available, warm is instant accessible and available. We've already done this calculation, so you are aware about this one. Then we have here the cold storage class access. I even explained to you already, so we are creating a copy of that one depending on the speed type, and we are charging here the restore request per speed type and restore volume per speed type, as well as the availability of the days. That's what we have already discussed. Now I give you another overview of this one. So accessing objects is more or less like this here. It's a simplified view, I know, but it's, I think, quite a good overview. So if you access a standard, you have the standard GET request, which you need to consider, nothing else. For warm, you have to consider the GET request and the restore volume. Because we have in the pricing and price list, you see there's a volume pricing for accessing the data, which is charged on volume, which means the file size or object size. For cold, it's a little bit more complicated. As you know, we have here the pay per restore speed, where you have to pay for the request and for the volume of or the file size or object size, however you would like to name it. For bulk, standard, and expedited, that's the reason why you see these 6 items inside the price list. In addition, the cold object storage buffer, which is basically, once you have restored, the availability of the object. I explained to you the availability of the object you have to pay for. That's this one here. And that's basically the cold object storage buffer. And of course, you have to even consider the cold GET requests. So that's the items which you need to consider. Those requests, GET requests, and the availability of the object once you restore it. And of course, here's a restore request and restore volume based on the speed type you select. So if you put it up here, you see here, GET request, restore storage fee, restore speed request, and restore speed volume. That's the 4 items you need to consider. So we are here quite advanced with understanding how this works as expected. So now we're going a little bit more into the details. So I hope that this is now clear for everyone. We have now this table here, which gives us a good overview about how the cost for which kind of action is calculated. Let's look a little bit more into the details. All requests which are done are accumulated. So all the standard requests which we have here on this layer, the put request, the get request, the delete request, and we will see in some slides there are a lot more requests, are put into the standard request and are accumulated then. And then based on this, we are doing the charging is done. Same for warm, they are accumulated, put into warm, put into cold, and then you see it here, we're putting them here. They are put into the standard object storage request, warm object storage request, cold object storage request. That's what we are currently doing from request point of view. And that's not all. There are much more OBS transactions than those which I now introduced to you. So put, get, delete, there is much more, and even the transition. And now I don't want to go into explain to you every detail of this overview which I give you. I will give you this overview, and you can, of course, as we will share, I think, the presentation as well as the recording, you can then get through this table. So here are all the request types and where they are accounted. I don't want to explain it to you in detail right now, but these are all the requests and where they are accounted to. So you can see this. And here's even an additional information which I added here. And for example, if, for example, optional, it could be object storage data transfer output cost could appear. If, for example, the early delete penalties can appear, because if you, for example, I already explained, if you move objects from one to a different storage class, then, for example, the early delete needs to be considered. And for warm, I called it EDW, and for cold, I called it EDC, so that you know, okay, this needs to be considered. Same for the warm object storage restore volume, RSV, I called it, and I marked it here once they are applicable for which kind of request. So this is the in-depth view. I don't want to bother you with that one, but if you want to look that up, you can, I think we are sharing the presentation, the recording, look this up, this table, and you see how this works. So as mentioned, we are accumulating all the request types. What I would like to mention to you here is based on the price list. I just calculated for you just roughly what is the cost, because you will say, okay, Daniel, what is the cost for this one? And here I just calculated how many requests you can make until €1 of payment is necessary. And you see here for standard requests is 230,000 in DE and nearly 330,000 in NL and so on. So just that you get a feeling about what is really the price for a request. That's the reason why I wanted to give you that one. I calculated, okay, how many requests can I do for €1? And that's the number which I have here for cold, warm, and standard. Just to give you a rough feeling about the pricing and how many transactions you need to do for €1. Good. Let's get to the next item. Here's once again the overview, the full overview, which I already have shown to you. I now created for you even another overview. So whatever you can read better, you can choose afterwards and select. So here you have the storage classes, standard, warm, cold. Here storing data, once again, what is charged here is accessing data. Here only the get request, here get request, and the restore volume. Here get request, code object storage buffer, bulk, standard, expedited. So it's a different kind of how we show it to you here, deletion of data. And here, once again, more or less what we have on the price list. On the price list, you see the standard request, the warm request, the cold request. You see the early delete warm, early delete cold. You see on the price list the expedited cost, standard, bulk for the volume and the request, the object storage buffer, and the cost. So here are all the items which you see on the price list. So I hope I was able to give you a good introduction into how pricing of OBS works. In case of questions, of course, you can always contact me. You will get my email address now in a couple of seconds. But first, I would like to go to the roadmap for OBS. And what I already mentioned is we have the OBS bucket default encryption. We have already released in the fourth quarter. I think it was around about October. This quarter, we are going to implement, and you already see what I've already introduced to you, the EM fine-grained policies. We are adding a functionality which allows you to upload larger objects via the UI or console of the OBS. And even provides a functionality that you can configure a custom domain if you use static website hosting. Because we received a lot of requests, or I would like to use my own domain when I use a static website hosting functionality. This is something we are going to implement even in Q1. I think it's scheduled for March now. And we hope that we will release then until end of March. So you will see, of course, make a review of the release notes and even the OTC community. So we will post always if a new release is done inside the OTC community. So subscribe to the topics. And of course, we're doing the release notes as well. So you will see that we are notifying here on both sides, the OTC community as well on the release notes. In Q2, we are working on releasing a new OBS browser version and a functionality which is called Parallel File System, which is supporting the POSIX file semantic. On Q3 and even midterm, I would say Q4 and even a little bit later, we're currently focusing on geo-replication. So we're considering here to have a geo-replicated OBS, where you can replicate the data even to the Amsterdam region. Of course, for OBS purpose, but even for the CBR. If you use, for example, the CBR backup functionality, and you need to maybe, and you want to even have it geo-redundant available, then of course the backups can even be fulfilled by a CBR. So we are looking into these both functionalities for OBS and for CBR. So, but of course the use case here is more or less which we see from CBR point of view, because a lot of customers from us are looking into doing the backups, storing backups geo-redundant to fulfill BSI requirements. And here we are providing then the out-of-the-box tool that you can have a geo-redundancy here available. Then for multi-part upload, we are putting a fragment lifecycle policy in place that allows you to delete then fragments which are uploaded by multi-parts after a specific period of time. And we will implement the S2I list object version 2 support. And what we're looking into is as well an object lock warm immutability functionality, how you would like to call it. That's even something which we're looking into. I am not sure if we can provide it in Q4 or even Q1 of 2023, but that's an item which we have on the work, which we're evaluating right now, which we would like to even bring into the OBS. So that's it from my side. This was a lot of content, I expect. And if you have questions, or maybe if you review the presentation, if you review the webinar, you can write me an email and contact me and ask questions. And I'm always here to help you, to assist you. And I'm even active in the OTC community, so you can even ask questions there. I will see these questions, will answer to them. So feel free to directly send them, put them, or better, I think, is even to post it inside the community, because maybe your question is even, and the answer to that is even helpful for someone else. So I would recommend to even post it on the OTC community so that the answer is given and everyone else, which is maybe searching for the same answer, can access these answers. That's even the best option that I would like to recommend to you. We are reviewing this, even I am reviewing it, and to see when there are questions upcoming. And Stefan is even reviewing it daily and informing everyone, hey, here's a question, we need an answer. So please feel free to always use the OTC community, because I think it's helpful for everyone if you ask a question and then an answer comes up, which everyone can review afterwards. That's it from my side. So thank you very much.
Yeah, thank you a lot, Daniel, for this time a little bit longer than usually webinar. Very, very great and deep insights into OBS. So thank you a lot here. Thank you to everyone who was here, our participant, who have joined this 1 hour and 15 minutes together with us. And with this, then I would say, see you in the next webinar, or read us all in the community. Thank you all. Bye.
Thank you. Bye.